Hi everyone, welcome back to my YouTube channel, Know About Embedded System. In today's video, we're going to understand one of the very important topic that is called as an interrupts. So what is an interrupt, how interrupts will work in the microcontroller, and how the ISR will be executed. That part we will understand in today's video. So before starting the video, if you're a new viewer to my channel, kindly subscribe my YouTube channel and get the knowledge of embedded system. So let us start the video here. Guys, in our embedded system, it is not possible to design any embedded system without interrupts. What is an interrupt and how interrupt works? So guys, interrupts is nothing but it's actually the disturbance, literal meaning, but in our technical terms, let us see here. So in an embedded system, interrupt is a signal that causes the processor to halt current task execution and start executing the special program called as ISR. So try to understand the word here. Interrupt is nothing but it's a signal. Interrupt is a signal which is generated from various different sources. Example, here you can see the interrupts can be generated from various different sources, and these sources are listed like this. So like the sources of interrupts can be timers or nothing but hardware components like timers, UART, SPI and so on, and even it can be software component. So whenever they need a service, they will send one signal called as interrupt signal. So in our embedded system, interrupt is nothing but it is a signal which is going to cause the processor to halt the current execution, and it will allow to execute the new task called as interrupt service routine. So that means whenever the service is required from various sources, they will send one signal to the processor to halt the main code and to start the interrupt service routine. So this is called as an interrupt. Interrupt is nothing but a signal which are generated from various sources to service your request. Is called as an interrupt. So we will understand with the diagram how the interrupt works. See here you can see this is your, let us assume my processor is running like this. Let us assume this is my processor is running the main code here, and here you can see at this point I'm getting an interrupt. Let us assume this is my main code, and here you can see this is my main code, the processor executing. So I'm getting one interrupt from the different source. The sources can be a software, sources can be a timer, sources can be UART, source can be a PWM. So these peripherals, whatever you are seeing, these peripherals will generate a signal to the processor. And so what processor will do? So processor will follow these steps. Here you can see some 4 to 5 steps are there. The processor will follow those 4 to 5 steps whenever there is an interrupt. So whenever there is an interrupt, so first thing is interrupt signal generation. The interrupt signals will be requested. Signals will be requested from the peripherals, as I told you already. So next step is whenever there is an interrupt, what will happen? Main program will pass. So this is my main program. So whenever there is an interrupt, the main processor will halt current execution. Nothing but it will just halt. It will stop the current execution. Not it is going to pause. Okay. So it is going to pause. The processor will pause current execution, and then here you can see there is third step. You can see context saving. The processor will have some previous information such as a stack pointer and a starting address, and some of the status information will be stored into the stack. This process is called as context store, we will call, and the informations which are available in the processor will be stored into the stack. So that is called as context store. Next one is get ISR address. To service the interrupts, whichever interrupt is generated, to service that interrupt, we have to develop the service routine code. Nothing but ISR we will call. So to get that ISR, there will be one unique address also will be provided for each ISR. That also we have to take. So that is called as get ISR address. To get the ISR address, we have to move to the vector table. So here whatever you are seeing in this vector table, for each interrupt service routine, there will be unique address will be stored in the vector table. So currently whatever you are seeing here, this is my vector table. Inside the vector table, for each interrupt there will be unique address. So processor will jump to interrupt vector table. Processor will take the respective interrupt service routine address from the vector table, and processor will jump to the ISR. So finally processor will come to ISR routine, and processor will execute ISR routine, and upon completion you can see the next step is interrupt service routine execution. And after completion of ISR, nothing but interrupt service routine execution, processor will restore the content. So it is going to initially processor will push the content to stack, and later it is going to pop nothing but retrieve the content which we have stored into the stack. That is called as a pop. Context, that is also called as context restore, and later resume to the main program. So after popping up the information from the stack, the processor will go back to main program and it will start executing your main code. So this is how the interrupt will execute, our interrupt execution procedure, interrupt service execution procedure. Okay, I hope this is clear. Now let us understand some of the basic informations related to interrupts. One is called interrupt service routine. So what do you mean by interrupt service routine? Here you can say the blue color, whatever you're seeing here. Interrupt service routine is nothing but a small function or a small code which is written to handle the particular interrupt. So if you have UART interrupt, we're supposed to write one small code for UART handler, and that is called as interrupt service routine. And this address, the interrupt service routine address, will be stored in the interrupt vector table here. Okay, this is called as interrupt service routine. Then interrupt controller. So what do you mean by interrupt controller? Interrupt controller means it is a hardware circuit which is going to configure the various interrupts and which is going to handle the different interrupts. So that will be taken care by interrupt controller. A hardware component that manages the interrupts is called as interrupt controller. Then we have interrupt vector table. That this is already I have explained. Interrupt vector table is nothing but it is a memory, a small memory allocated to handle the interrupt vector address. So if you have 10 different, if let us assume I have 16 different interrupts, for each interrupt service routine there will be unique address that is stored in the interrupt vector table. So what is the role of interrupt vector table? Which is going to store the interrupt service routine address. Context store. I have already told you what do you mean by context store. Context store means whenever there is an interrupt, the processor automatically stores the current task information into the stack. This is called as context store. Then we have context restore. So whenever after completion of interrupt service routine execution, processor will restore the context which are stored in the stack. This process is called as context restore. Okay, these are all important things related to interrupts and interrupt service routine. There are different types of interrupts available. So one by one we will see. One is called hardware interrupts. Hardware interrupt means the interrupts generated from various peripherals which are available inside the microcontroller. So such as UART, timer, PWM, I2C, and so on. These are all coming under hardware interrupts. Software interrupts. Software interrupts is a very straightforward definition. It is nothing but the interrupt generated from software. Example, divided by 0. So this is the best example of a divided by 0, or whenever you exceed with your limit. If your number is a character type 8-bit, and if you're going with a more than 8-bit, then that's going to generate something called as software interrupt. Then external interrupt. External interrupt means interrupts generated from external world is called as external interrupt. So usually external interrupts nothing but the kind of switch or kind of external pins. These external interrupts will be generated from the external events. This is called as external interrupts. Internal interrupts are nothing but hardware interrupts. Again, it is similar to our UART, SPI, I2C, and CAN. And then we have different types of, again, maskable interrupts. What do you mean by maskable interrupts? Maskable interrupt means you can ignore the interrupt. If there is an interrupt, you can just ignore that interrupt. Is called as a maskable interrupt. So maskable interrupts are those processor can temporarily ignore, or the processor can delay the interrupt. Is called as interrupt service routine can be delayed. Is called as maskable interrupt. Okay. The non-maskable interrupt. Non-maskable is nothing but higher priority interrupts. At any point of time, if there is a non-maskable interrupt, the processor has to service that non-maskable interrupt. Vector interrupt. Vector interrupt means I have already told what you mean by vector table. The same thing again I need to repeat here. Vector interrupt means each interrupt service routine will have a proper address in the interrupt vector table. That type of interrupts are called as vector interrupts. So in an interrupting device sends a specific code or a specific address to the CPU, which uses the vector table. So by using vector table, processor will jump to the interrupt service routine. So that type of interrupts are called as vector interrupt. The next one is called non-vector interrupt. Non-vector interrupt in the sense there will be no specific address. There will be no specific address and there will be no any vector table available for that particular interrupt. Such type of interrupts are called as non-vector interrupt. No vector address, no ISR address, and no specific code is going to be defined in the non-vector interrupts. Non-vector interrupts. That type of interrupts are called as non-vector interrupts. So we have priority schemes here. There are different priority schemes available for scheduling the priority of an interrupt. The first one is called fixed priority scheme. So in this fixed priority scheme, if you have multiple interrupts, these multiple interrupts will have its own priorities, like priority number 0, priority number 1, and priority number 2. Like that, there will be standard priorities will be available for each interrupt. That is called as fixed priority interrupts. In case of dynamic priority scheme, the priority of the interrupt can be changed based on the interrupt condition. In case of fixed priority, it is not possible to change the priority, but in case of dynamic priority scheme, it is possible to change the priorities based on the conditions. That is called as dynamic priority scheme. Vector interrupt scheme. So here already we have explained what you mean by vector interrupt scheme. So in the vector interrupt scheme, every interrupt will have its own particular interrupt service routine address, and particular interrupt number is called as vector interrupt scheme. Then priority masking. What do you mean by priority masking? So priority masking means you can mask the priority which are having the less priority. The interrupts which are having a less priority, you can mask them. That is called as priority masking. So this scheme allows lower priority interrupts can be temporarily disabled or temporarily masked. Is called as priority masking. It is going to handle only higher priority interrupts. That is called as priority masking. Then we have round robin priority scheme. So round robin means one after the other. If you have 10 interrupts, the first interrupt 1, 2, 3, 4, again it will start from 1. Like that, one by one interrupts will be prioritized, and one by one interrupt service routine will be executed. So this type of priority algorithms is called as round robin priority scheme. So these are all the different priority schemes. So in this video, we have understood what is an interrupt, what happens when interrupt occurs, and some of the basic definitions of the interrupts we have understood. So I hope this video is clear to all. So if you feel this video is informative, please click on like button and subscribe my YouTube channel. Know about embedded system. Thank you for watching.